Hi there, welcome to another section. So in this section, I'll walk you through how you can download or extract time series data from Google's Earth Engine to your Google's Drive in a CSV format. So this is an example of the type of data set you look at extracting in this series. So this data set consists of 3 hourly precipitation data from the month of 20 for the month of January in 2016, and it ranges of data begins from 31st of January 2016 to 1st of February 2016. Now this data is calculated over each state in Nigeria. So each row here signifies states in Nigeria, while each column signifies hourly precipitation value. So the first one is hourly precipitation value at hour 3, the 1st of January, hour 6, hour 9, hour 12, hour 15, and so on. So at the end of this section, you will learn how to export such data type in Google's Earth Engine. So let's go to Google's Earth Engine. So this is our Google's Earth Engine interface. So I already wrote a script on doing this, and I'm going to walk you through the script. This is the script. Now this is the script. Now the first thing you want to do is, which data set do we want to get station value from? We have a data set on Google's Engine called TRM3B42. So let's learn about TRM3B42. Sorry about that. TRM. So this TRM3B42. So let's open. So this TRM3B42 is from here. It is 3 hourly precipitation estimate. So this data set ranges from 1998 to present. So for every 3 hours from 1998 to this present day, it captures the tropical rainfall, that's that tropical rainfall major emission, which are the climate value, that precipitation value. Look at the values it captures: precipitation value, HQ precipitation, IR precipitation value for every 3 hours. Now this data set, it's a joint work from NASA and Japan Aerospace Exploration Agency, that's JAXA. So from this data set, that this image data set, we'll try to get this precipitation value. I check the band name, it released as precipitation value to get the precipitation value. So what we would be doing, let's go to our now. If you observe, this is the ID for this data set as seen here. This is the ID. If you want to import your script, this ID, image collection of images at different period in time. So the first thing we're going to be doing is we load our data set. But before we do that, now we have an area of interest we are considering of getting the data from. So our area of interest is Nigeria. In Nigeria. So for each state in Nigeria, I want to get precipitation value, 3 hour precipitation value. So I need to load my area of interest shapefile. That's a geometry of Nigeria that shows each state in it. So I already have it here imported to my script, but I'll show you how you can do that. So you click on new shapefile to load, then you select the file. So you see it's this Nigeria state is an S3 shapefile with its metadata added to it. So how you load it open. Now you must make sure all five of these data types are complete, else the data set will not be loaded. So I can rename my data set to any name I like. Now it's showing me the asset ID already exists because I already have its asset on my notebook. So if it wasn't there, I would do done, let's say, let me change the name to tests. Then I upload the data set, then it shows you the tax, the status of the upload. So once that is done, you see your asset, that's the shapefile here under this asset. Then you now load it by clicking on import script. So I've already done that already here. So I can delete this. So you can rename based on your name you like. So now my shapefile is loaded to my scripts. Next thing I'm going to do is I have my image data from Google's Earth. I'm going to filter this image data to limit it only to a specific period of time I'm interested in. So I'm interested in 2015, 2016, in the month of January only. That's why I call filter dots year range 2015, 2016. If I want another from 2015 to 2017, I'll change it to 2017. If I want, then from after filtering the year, then I'll filter the month. Then if I wanted month to be from 1st of January to 2nd of January, so if to first from the month of January to February, I'll change it from 1st to 2. This month signifies, this value signifies the type of dates you're interested in, so this month. Then if I'm trying in February, I could change it to 3 and so on and so forth. So I just want only January. Then the next thing I'm going to do after filtering, I've also filter by my area of interest. Now, my area of interest is Nigeria, so I call my shape file that was already been loaded here and save it as, sorry, and filter, I call this filter band, then put my area of interest as the input parameter in this function. Then the next thing that's going to happen is once I've gotten my area of interest, I've gotten my specific period of time of my specific period of time of data. Next thing I'm going to do, I'm going to select the band of interest. That's my precipitation data. Now remember, this data set has different bands. It has different bands. Precipitation, relative error, each image has different values for it. Now I'm only interested in my precipitation band, the band called precipitation. So that's why I'm using precipitation. If I'm interested in IR band, I will change IR precipitation band or HQ precipitation that I'll change the value here to IR, or I'll change the value here to HQ. So then I store my value as precipitation. Then let's print out this value and see what comes up. So from here, you can see that it shows you 744 element image collection, 744 elements, because of from 2015 to 2017. I want to limit to 2016 only. And if you run this, you see it show you so it shows you 496 elements. So how come about this value? For each month, we have 31 days in each month. So for each day in January, we have about 31 days. Now we are looking at 2 years, 2015, 2016. So we'll have about 62. That's a combination of months in the 2 years. Then our data set returns 3 hourly precipitation that value in each day. So that is a total of 8 image or 8 image value data in each day. So as for each 3 hours, we have 24 hours in a day. We divide 3 by 24, you have 8 unique value in a day. Then if you multiply 8 by 62, that's 62 the total number of months in the 2 years. then you're going to have 496 elements. So 496 elements signify 496 image, 496 precipitation for each 3 hourly value. So you see the first image at hour 3, at hour 6, hour 9, hour 12, hour 15, and so on. Then the next line, this line of code shows the size of my precipitation value, as I've already said, 496, and the size of my shape value, that's my area of interest, my shapefile, that's 37. Now, our main goal is to get 37 rows. The 37 rows signifies each state in Nigeria, and why then 37 rows and 496 columns. The 496 represent the hourly precipitation value over this given period of time. So let me show you, look at our shapefile. So if you click on this shapefile here, now assets, once it loads, you will see the number of features, 37, that's 37 rows. And you see the geometry here. So it consists of each polygon in this shapefile consists of states in Nigeria. Then next thing we're going to be doing now is to convert our data sets, the precipitation data, from image collection to single image with multi-band. Now, before, this image collection consists of collections of image, as the name says, but now we want a single image with multi-band. Now, why do we want a single image? We want a single image because it's very much easier to carry out statistical calculation of an image over a region than to carry out statistical calculation of a collection of image over a region. So we need to convert these collections of image to single image in multiple band, whereby each band will signify each image. So the next thing we'll be doing, so I'll run you through the line of code that would help us to convert our image collection data to single image. So this is the line of code under this function. So I'll copy, let me print, let me see, I will print line of code. So it's called, you call the image collection dot to band. So if you run this line of code, if you run this script, once it loads, you will see our image collection now is single image with 496 band compared to the previous, which was collections of image. So each band signifies each image. So these are the band from each hour, 1st of January 2015, hour 3, hour 6, hour 9, hourly precipitation value. Then the next thing we're doing is, now we've had an idea on how we want to convert our function to band, but I wrote a script in such a way that while we convert our values to band, we can easily rename it to date time name. So we want the name of our band to, we want to eliminate these redundant values and make it just the year, the month, the day, and the hour. So this is where this function comes in. So I wrote function. This function calls reduce image image collection to band. So what it does, it takes in image collection, it converts the image collection to a band. After converting this image collection to a band, now for each band in the image collection, that's what this one does, because the name.map. So it maps each band in the image collection and try to rename the band. So it renames each band by eliminating the first precis from 3b4 to, so it takes from the fifth element with the fifth string values to, let's say I can slice to the 18th value, or if I am interested in taking off the precipitation value. So if I run this line of code, so it returns image collection. So I call this function here called image collection to band precipitation. I put in my precipitation value, which was my precipitation value, which was an image collection as input here, and I call this my function. Then let me print out this value and see what it shows. So you can see that our 3-hourly precipitation value in a single image format. So let's check out the names of the, so you'll be observed now that you can see that it has been renamed, but 7 value, these other values are changed. So I can limit it to 16. So if I limit it to 16, I run this again. So once it's complete, let's look at our band names again. Band. So now I see I've been able to extract only the year, the day, the month, and the hour of precipitation. So now, having done that, now we now have our image collector 3-hourly precipitation value in an image with multi-band, whereby the bands are being renamed with the name, with the month, the year, the day, and the hour. Now, the next thing we're going to do is, now we now have our image data, our precipitation data in the correct form. We have not, next step for us to do is to carry out statistical calculation of that precipitation value, that's the image precipitation value over each region in our area of interest. So for example, we want to get the mean precipitation value in each geometry, or in each state in Nigeria in a particular 3-hourly precipitation value for each state in Nigeria. That's the mean value. So what we'll be doing is we'll call this function. So this line of code will help us to calculate the mean 3-hour precipitation over each region in our area of interest. Our area of interest in Nigeria. So what happens is this: we will call our image value. I will call a function called .reduce region. Now in this reduce region, we'll pass in our collection, that's our area of interest, Nigerian states, to collection. Now we'll select admin eng, that's the feature, the column name called admin eng. We'll have it selecting this feature. Now we don't want, let me show you our geometry value. If you see the features, it has different features, different columns. Now we don't want it to pass all these columns as our output. We only want it to pass only one single column that is unique. And now a single column that is unique and is more reasonable for our use is this admin admin1 eng. So we'll be selecting only this admin eng value at our in our area of interest. That's what I call this. So we now call the reducer, that's this, what statistics do we want to run for our image over that region. So I'm going to call reducer.mean. Now if I wanted the maximum rainfall for each 3 hours in Lagos, I would use e.max. If I wanted the minimum, I would do e.mean, but I want the mean for the 3 hourly precipitation value, or if I wanted the sum, I would have this sum. So it depends on the statistical calculation you want to carry out. So to learn more about it, you can check on documentation, Google's engine documentation. So this is reducer. Sorry about that. This reducer. So this reducer will give you an idea on different exact calculation you can carry over a region and an image. So once this line of code is done, let's run this. So if I run this script, click on run here. It keeps on running. So once it completes, once this line of code, this function finishes, you will see our calculated statistics over our region, precipitation value over our region. So you'll see that now we have 37 elements with 496 columns, whereby each element represents each state in Nigeria, while each column represents 3 hourly precipitation value from in 2015-2016, the month of January. So you look at the features, they are all in code. These are our precipitation. These are our precipitation values in 3 hourly. So the next thing we're going to do now is we're going to save this feature collection as a CSV file in our Google Drive. So we'll call this line of code. So what is called export.table.to-drive. So it takes in the collection, that's the output of the statistical calculation of precipitation over a region. That is this 3 hourly precipitation. Now, I want it to take off geometry value for each road or for each region. I don't want the geometry value, so that's why I'm passing this select null value. Then description, what's the name of my data set, in the file prefaces, then the folder. Now it's advisable that before you carry out this, before you export the data set, you must have a specific folder in your Google Drive that you can save this on completion of this. And what's my file format? I'm looking at CSV file. So if I run this line of code, if I run this, you see my tax shows orange. So I go to tax, it shows me 3 hour precipitation values. I need to run this function. So the tax name, what should show as running, the Google Drive folder and the file name. I've already specified them on my script. So if I click run here, it starts running. So once it's complete, it should show a blue tick like the rest of them over here. So once it's successful, you'll see this tax bar changes to blue and you have a marked So now, next thing I'm going to do is to go to our folder on Google Drive, this folder, to check for our data sets. So let's go to Google Drive. Okay, Timeseries is already there. So this is our data sets. So if I click on this, inspect, then I open Google Sheet. So once that is done, you can see this value. So on that, we now have our 3-hourly precipitation value for each state in Nigeria for the month of January in 2015-2016. So these are the states' name. So it gives the each hour, first, third hour, 6th hour, 9th hour, 12, 15 hour, and so on until it reaches the month of 2015. So that's also for there. From then you can download this data, carry out any analysis of your choice on any tool of your choice, Microsoft Excel, Power BI, or R. That is all for now. Thank you for your time. So if you have any question or any comment or any observation you would like to make this video, you can do that right on the comment section. Bye-bye. Have a nice day.